Hey, welcome to what I would call, oh, where did I put that? Etc. I think I missed a few things. Etc. I forgot to include some things, so I thought we would talk about just a few miscellaneous subjects. One, ages of mountains. Just like rivers, we can classify mountains according to their age. Are they still being formed? Are they in between? Or were they formed long ago and all they are doing is wearing down? This is one of my etc. topics. These obviously are young mountains. Craggy, still rising, not a lot of soil. These are young mountains with a long lens camera shot, by the way. These are the Grand Tetons in, is it Wyoming? I believe so. This is just beautiful. This is part of a fault block system. An entire area has been stretched out, and these guys have raised up. This part has dropped down. Here are mature mountains. Take a look at the difference. And then here are what we call old mountains, the kind of thing you find back in the Appalachians. They're very rounded, well-defined drainage, not a lot of elevation change compared with this kind of thing. People from back east who live among the old mountains, like the Appalachians, the Alleghenies, the Whites, I forget a few others back there. But they're always surprised when they come out to Phoenix and we have things, well, kind of like this, but not quite. So we have young, mature, and old mountains. One of the et ceteras. Next, the major mountain ranges. I went across them really quickly, but I think too quickly, and I want you to know them, so here we go. We have the Rocky Mountain Range and the Andes. Now they can be broken down into the Atlantic Coastal Range. You have the Coastal Range and the Cascades in here. These, if I'm looking right, are the Sierra Nevadas. Hard to tell. And then back here, although it doesn't look like it, these are mountains. These are extremely old, folded mountains, the Appalachians. Again, these are the Andes. The Atlas Mountains are right across here where Africa is bumping into Europe. And the European component of that are the Pyrenees and the Alps, right across here, and the Caucasus. Over here, where the Indian plate is going or banging into the Asian plate, you have the Himalayas. And that's it for the major mountain ranges. Oops, I left out the Urals, my bad. And you have the same kind of thing going on over here that you have in Alaska, a lot of accretionary terrains. Okay, normal faulting. In Arizona, we have a really big normal fault. It is called the Mogollon Rim, and it stretches all here across Arizona. If you ever go up on the way to Winslow, the most important town in Arizona, and pass Pine and Payson, between Pine and Payson, you will run into, whoops, this. This is a large normal fault. Now the fault itself is further out. What's happened is the escarpment, or the face of the fault, has eroded back over the years. And yes, there has been a fire up here. I think this was part of the Dude Fire back in the 80s or the 70s. Still a lot of destruction there. By the way, right here is what's called a monocline. You have lowland here, then it rises up and goes to the highland here, which is the plateau that forms the Grand Canyon, the Kaibab Plateau. And the plateau itself is bisected by the Colorado River. Here's the North Kaibab and the South Kaibab. The North Kaibab is about 1,000 feet higher than the South. All right, next. We have normal faulting in the Phoenix area. Here's a fault block mountain. This is kind of convenient because this is the same as this. It's just that the real one is tilted more. This is broken and tipped back, and you will find this all over in the Phoenix Mountains. This is really kind of cool. Oops, let's get rid of that topic. Ignore that. That has nothing to do with this. We've talked about this briefly, but I wanted to clear up a few things. Anticlinal traps form in sedimentary rocks. And you get them when you have a shale rock as a cap. Remember how shale won't let water down from the top? Well, the same thing happens when oil, water, and gas, natural gas, try and rise up through the rock. They can't. Now, the water is down here, it's trapped. The oil and the gas are less dense than the water, so they go on top. The water, or the rock in which the oil, the gas, and the water are trapped is sandstone. Those are just a few important things I thought I'd point out. Again, fault block mountains. The Tetons that I showed you a while ago, the Tetons. This is the edge of the fault block front. This is the edge of the Tetons. That picture was taken from over here. Here's the little barn. These guys have faulted up and then eroded back. And it's happening because of tension. These pieces of the plate are being pulled on. And why are they being pulled on? Well, over here, the Pacific plate is going underneath North America. And as it does, it stretches out North America because we're resting on top of it. Here's Steens Mountain, another fault block mountain. Here's the fault face. It could have been way out here somewhere, but it is eroded back over time. Oops. And again, folded mountains, anticline and a syncline. Now, this is kind of weird because the drawing isn't exactly right. The anticlines most often make the valleys because these rocks are worn down, and the synclines being squished together quite often make the hills. Where do you see folded mountains? Again, the Appalachian Mountains back east. Tennessee, Kentucky, Pennsylvania, that kind of area. If you put a towel on top of your table and squished it together, you would get this kind of wrinkling. This is looking down on top of the towel or on top of the landforms back east. Now, isostasy. This is something people don't think about. Here's a wood block floating in water. If you add some weight on it, the wood block will float a little bit lower. If you take the lead weight off, the block will float a little higher. Well, the crust of the earth is the same way. We are floating in the mantle. And if some of the stuff is eroded off the top, the crust will bounce back. We're kind of like an iceberg in that most of our stuff is actually below what we would call the water line or the median line. Every time you see a mountain, it has roots that go down into the mantle very far. Just something to think about. When the top of the mountain wears down, this bounces up a little. Wear some more off, this bounces up. Joints and faults. You know that faults are lines along which there's been movement, but joints are just cracks in the rock. These are joints in rock. This is in, I want to say Scotland, I'm not sure, but this is just a joint set where rock is cracked. There's no movement. But this is a great place for water and roots to get down in, and then they crack apart rock. This looks like Devil's Tower in Wyoming, but it's actually somewhere in the mid-east, I think. And this is what's called columnar jointing. When basalt comes up through the ground and cools, it cracks into these hexagonal columns, which are really kind of cool. But those are joints. They aren't faults. This is a joint, and along this joint, after it formed, hot molten material went in there. Now, one of the last things to solidify, believe it or not, is quartz. Even though it's resistant, it has a fairly low melting point. And with quartz, quite often, you will find metals. In this case, you have a lot of iron, and I don't know, something looking kind of goldy there. You think that's why prospectors went after veins of quartz, like they used to do just north of the 101 on 16th Street? Go back in there and you'll find all kinds of veins of quartzite, or quartz, that the miners were going after. And this is my fault. I actually own it. Okay, I don't own it, but this is not a joint. This really is a fault, and this is on I-40 / Route 66 on the way to Kingman / Las Vegas. And this looks like a normal fault. The footwall, oops, yeah, the footwall, oh, kind of hard to tell. The footwall has moved up and the hanging wall has moved down. This is really kind of cool. That's it. Thanks for watching.